Hello everyone, I am Swanlata, working as an assistant professor of mathematics in B.V. Raju Institute of Technology. In this video, I am going to cover sampling methods, first unit topics, that is sampling technique. So firstly, let us begin with definitions. The definitions are very important in these sampling techniques. Population, the aggregate of the observations, totality of the statistical data to form the subject of investigation is called it as the population. Examples are the population of the heights of Indian. So nothing but the collection of data. So based on our requirement, whatever that information we need to, we want to collect. So collecting of all observations is called it as population. The number of observations in population denoted as capital N. So the number of observations of that population denoted as the population size. It may be finite or infinite. It is denoted by the symbol capital letter N. So here, as the study of this entire population is not possible based on the time, money, labor, so it may take lots of durations, lots of time. So studying of entire population is not possible. That is why the portion of that population we need to select for analyzing of that data. So for that point of view, we are selecting the sample. Sample is nothing but the portion of the population and the number of observations in that sample is called it as sample size. So sample is nothing but the subset of the population. Suppose when we go for a shop to buy a bag of rice, how can we check? We need to consider some handful of rice from that bag, and whatever that portion we took from that bag, we are checking that quantity, and based on that whether we are going to buy that bag of rice or not. That is why. So meaning of that is if that portion of whatever that portion we have selected from that bag, that is called it as sample. If that portion is good, we are willing to buy that bag of rice. Meaning of that means we are expecting whatever that quality we got from that portion, we are expecting the bag of rice are also containing that quantity. So if that bag of rice having that type of quality, whatever that sample we have selected, so that is going to be the proper sample. So meaning means that is the proper sample. To selecting of that type of proper sample, we are using different sampling methods. Here this we are mainly using two types of sampling methods. Those are random sampling or probability sampling, and non-random sampling or non-probability sampling. So first we discuss with that random sampling or probability sampling. Mainly most frequently we are using three types of sampling methods. So the process of selecting of these samples are called it as the sampling. Okay, so in this random sampling, mainly we focus on three types of random samples: simple random sampling, stratified random sampling, and systematic sampling. So first we start with that simple random sampling. Here this is the process of selecting of the sample from the population. Each sample having the members included in that sample having the equal chance. So the way of selecting of that samples in random manner, that is called it as the simple random sampling. So examples are handful of cards selecting from the well shuffled pack of cards or lottery system. These are the examples of the simple random sampling. And in this simple random sampling, the way of presentation, the representative samples can be selected in two ways. That is simple random sampling with replacement and simple random sampling without replacement. So in simple random sampling without replacement, suppose if the population size capital N and the sample size denoting with small n, so the number of possibles get in the simple random sampling without replacement is capital NCN, and in simple random sampling with replacement case, that is capital N power small n. And stratified random sampling. So in this, whenever the population is heterogeneous, what is the meaning of heterogeneous? Means it is not in homogeneous way. Okay, so when heterogeneous data, first we divided into some groups or blocks. Those groups call it as the strata. After dividing, that strata can be divided based on some characteristics. If it is homogeneous among of that strata, for each strata we are selecting the samples by using of that simple random sampling technique. So the way of selecting samples is called it as the stratified random sampling. When we combining of all these samples, we get the stratified random sampling. And the third one is systematic sampling or quasi-random sampling. So in this, the samples can be selected from that population. It may follow some order. Means here the first, the interval size, the number of populations, the number of samples are selected from the population, the interval size is denoted, and here the whatever that first unit, that should be selected by random manner. And from that first unit, using of that kth interval, the number of samples can be selected by following some order. So this is the in this way the samples are selected in that from that population. So the way of selecting of that samples is called it as the systematic sampling. And coming to the non-probability sampling methods, these are two types: purposive or judgment sampling. So here, whatever that sampling procedure, this chosen from that population, this does not depend on some scientific procedure. Means here, this purely depends on the individual choice and that personal convenience, and all whatever that unit selected, sample unit selected from that population based on this method, all are having not equal chance. So the individual, it entirely the members selected from that population entirely depends on the individual choice. And second method, sequential sampling method. So it consists of sequence of samples drawn from the population one after another. Suppose if the first sample is selected, and when we testing of that sample, if it is if it is not accepted, again we based on this we are selecting the second sample. Again we are checking that sample. If it is good, where we are processing of we are checking of this process continuous till when we get the proper decision. So if that whatever that first sample, if it is acceptable, then we stop that selecting procedure. So these type of number of selections of samples can be made in this sequential sampling. And classification of samples. So here, based on that sample size, the samples can be divided into two types: large sample and small sample. If sample size n greater than or equal to 30, the sample call it as the large sample, and if sample size small n is less than 30, that corresponding sample we call it as the small sample. And here the parameter, meaning of that is, parameter is nothing but statistical. It is one of the statistical measures, this based on the population observations. Examples are population mean, population variance, population standard deviation, whatever that calculations we made based on that population, that constants we call it as the parameter. And statistic, so this is also a statistical measure. It's based on the sample observations. The sample constants are called as the statistic. That is, examples are sample mean, x bar, sample variance, s square, and sample standard deviation. That sample standard deviation, we call it as the standard error. And next, the important theorem, that is central limit theorem. So whenever if the data is not not follows that normal pattern, we need to convert into normal pattern by this central limit theorem is very useful. So based on this, whenever that sample size increases, whatever the result it gives, it is reaches to the true value of the population values. Here the statement of this central limit theorem is, if x bar be the mean of the random sample of size n drawn from the population having mean, mu and standard deviation sigma, then the sampling distribution of the sample mean x bar is approximately normal distribution with mean, mu and standard deviation, that is the standard error of that mean, is equal to sigma by root n. So this is possible only when n tends to infinity. So if n is large, the sampling distribution of that sample mean and variance, it is nearer to the population mean and population variance. And next, standard error of a statistic. The standard error of a statistic T is defined it as the standard error of the sample mean is the standard deviation of the sampling distribution of sample mean. So here I mentioned some formulae for the standard error formulae for different statistics. Here the standard error of sample mean x bar is equal to sigma by root n. So symbolically we are denoting with standard error of x bar, that is sigma by root n. And standard error of proportion formula is square root of pq by n, and that is SE of P. Proportions, we are doing sample proportion, the symbol is small p. The formula for this is under root of P capital Q by N. Here capital P is the population proportion. Proportion is nothing but probability. So the ratio of the number of favorable cases by the total number of cases. So that is the proportion. So here Q is equal to 1 minus P, and here the standard error of the difference between two sample means, difference means x1 bar minus x2 bar. So standard error means SE of x1 bar minus x2 bar is equal to under root of sigma 1 square by n1 plus sigma 2 square by n2. And difference of two proportions, that is SE of p1 minus p2 is equal to under root of p1 q1 by n1 plus p2 q2 by n2. So these are the some of the statistics we are using in this unit, and these are useful for this statistical method paper. So these are very important. Before starting the problems, we should know some notations and terminologies. Here the population size, as we know, the population size denoted with capital N, and sample size, it's denoted with small n. And the population mean, the symbol is mu. The population mean denoted with mu. Suppose if the observations if we denote with that capital whatever the population values, we are denoting with capital letters. So if the number of observations we may denote with xi, so the population mean mu is equal to summation of xi by capital N is sum of the population observations by number of observations. So here the number of observations in sample denoting with small xi, and here the sample mean denoting with x bar. X bar is equal to summation of xi by small n. And variance, coming to the population, the population variance sigma square. So formula is summation of xi minus mu whole square by capital N. So meaning of this is, so this is the summation, sum of the squares of the observations. Observations are nothing but the given population values. Observations are deviated from their mean. Sum of the squares of the observations deviated from their mean. So divide with total population size, it gives the population variance. So here sample variance we are denoting with S square. So here in place of capital letters we are using small symbols, that is xi minus x bar by small n. So here summation, this is running from I is equal to 1 to n, and in population the summation is running from I is equal to 1 to capital N. So sum of the, here also in sample variance, some of the observations are deviated from the mean. Here sample mean, x bar is the sample mean. Some of the squares of the observations are deviated from their mean, and this total part, total numerator part divided with sample size n, then it gives the sample variance S square. And next coming to the population standard deviation. Population standard deviation denoted with sigma. The formula for this is under root of variance. So this is equal to square root of sigma square. Here S square is equal to under root of variance. So this is the sample standard deviation, that is S is equal to under root of S square. So these are the notations for the population and sample. So now we are doing, I'm going to explain problems on simple random sampling with replacement case, without replacement problems. So these two cases are very important. So in simple random sampling, the sample can be selected in two ways, that is simple random sampling with replacement and simple random sampling without replacement. So SRSWR is the simple random sampling with replacement, and SRSWR is the simple random sampling without replacement. So here in the simple random sampling with replacement, it comes under the infinite case. Infinite means here the number of samples are repeated. So is this simple random sampling without replacement, this comes under the finite case. So finite means here the number of samples drawn by using of this method from the population, the observations are not repeated. So this comes under the finite case. In simple random sampling with replacement, the total possible number of samples can be selected by using the formula capital N power small n, and this simple random sampling without replacement, the total number of possible samples can be selected with the NC ways, means capital N, C, N ways. Here N is equal to, capital N is equal to population size and small n is equal to sample size. And now we'll start the problem. Here first, here the given problem, if the population is 3, 6, 9, 15, 27, and here what did they ask? List all possible samples of size 3 that can be drawn without replacement from the finite population. And second question, calculate the mean of the finite population and find the standard deviation of sampling distribution of means. So here first read the given problem, and in the given problem, whatever the population values mentioned, those are the given population values. So here that xi is equal to 3, 6, 9, 15, 27. So first, whatever the population values we have, first we should calculate the population mean and population variance. So here the population size n is equal to 5, the population mean mu. So formula is summation of xi by capital N. So here summation of xi is equal to sum of all these xi values, that is 3 plus 6 plus 9 plus 15 plus 27, and here the size capital N is equal to 5. When we do the calculations and after simplifying of this, you will get this 12. And population variance. So variance, what is our variance formula? Summation of I is equal to, here capital N, I is running from 1 to 5, and xi minus mu whole square by capital N. So here when we expanding of this summation, here we may get this x1 minus mu whole square plus x2 minus mu whole square plus and so on, plus x5, last observation, here we have 5 values now, so that value, last value 5 by 5. So here x1 is equal to, this is x1, x2, x3, x4, x5. So applying of this formula, by using of this formula, here we get this one, and when we simplifying of this, we will get the population variance. And here what is our first, what did they ask? The first question is, what are the possible samples we get if the samples are, the 3 samples are selected from the population without replacement, what is the sampling distribution? So here the number of sample size is 3, and those 3 can be selected by using the process without replacement. So our formula is NCN. So here how many samples we get? 10 samples, 10 possible samples we may get from that population 5. Our population size is 5. So here the possible 10 samples are, here what is our population size? That is 3, 6, 9, 15, 27. So in this population we need to select 3 samples by using of that with 3 without replacement case. So here the first combination is 3, 6, 9, and second combination 3, 6, 15, and means in each that samples 3 observations we need to select from that among of that 5. So here the next pair 3, 6, 27, and we completed that 3 part now. Next we start with that 6, 6, 9, 6, 9, 15, and 6, 9, 6, 9, 27, and next 6, 15, 27, and last pair 9, 15, 27. So here selecting that they mentioned that sample size is 3 means the 3 pair of the combination of 3 samples we need to select from that population. So those combinations are appeared like this. Here, after getting of the 10 samples, for each combination we need to find the mean. Means here, whatever these 10 samples we get, so finding the corresponding sample means of this. So here, do the 6 means, if you do the average of this first sample, 3 plus 6 plus 9, so if you do the average of this first sample, that gives 6, and this 8 may come from the average of 3 plus 6 plus 15 by 3. So like that, for each pair of samples, for each combination of these samples, we need to collect, we should calculate the mean. Whatever that set of all these sample means is called it as the sampling means of sampling distribution of means. And here, in that second bit, they ask find the mean of the sampling distribution of mean. So here we get the sampling distribution of mean. Sampling distribution of means. Isn't it? Okay, so here, using of this, again we calculate the mean for these all 10 samples. We get the mean of the sampling distribution of mean. So that denoting with mu x bar. So mu x bar is equal to mean of all these 10 values. So mean means here we are adding 10 values in numerator. So how many values we have added? So we need to divide that number. So that is why here that is 10. So after simplifying of this, you will get 12. And sampling variance of the sampling distribution, and third bit, they have given the third bit, find the standard deviation of the sampling distribution of means. So standard deviation means first we should calculate the variance. So the variance of the sampling distribution of means formula, this sigma x bar square is equal to x bar I minus mu x bar whole square by number of observations 10. So if you simplifying of this, here you will get that 12. So this is the this indicates the variance of the sampling distribution of the means, sampling distribution means. But here we need to calculate the variance in simple random sampling without replacement. So in simple random sampling without replacement, the variance formula is sigma square by n into capital N minus small n by small n minus 1. Here sigma square is nothing but population variance. Already we calculated that value, that is 72 we got, and n is population size, that is 5, and small n is sample size, that is 3. So if you all these values we have substituted these values in this formula, we will get 12. So means when we calculate the variance by using of that sampling distribution means are the variance of the sample without replacement. These two means, whenever you calculate these two means, these two values, variance values, you will get same value. So this is the standard deviation of the sampling distribution means square root of variance. So this is the solution for that first problem. And second problem, here the population consists of 5 members, 2, 3, 6, 8 and 11. Consider all possible samples of size 2 which can be drawn with replacement from this population. And here Find the mean of the population. They asked that find mean of the population, standard deviation of the population, and the mean of the sampling distribution of means, and the variance standard deviation of the sampling distribution of means. So here the given population values are xi is 2, 3, 6, 8 and 11. And here the sample size in this, among of all this population, the sample size is, they mentioned that it has 2, means 2 possible samples we are going to select from that population by using of that with replacement procedure. Okay, so first whatever the problem, first we should calculate the population mean. So here that they asked that the population mean is summation, as we know the formula, that is summation xi by n. So these are the xi values. So sum of do the sum of all the given values and divide with the number of sample size. Here this is 1 by capital N. So sigma square is equal to summation I is equal to 1 to n xi minus mu whole square by capital N. So if you apply this formula in place of xi, that given values are comes. Okay, so after expanding of this summation and substituting the values of that given xi and mu, just now we got that value 6 now. So after computing of all this, you will get that sigma square value. So the sigma is the population standard deviation. So this is equal to under root of that variance. If you do the root of 10.18 value, you will get 3.29. So that is the population standard deviation sigma value. And here the third bit, what did they ask? Third bit, find the mean of the sampling distribution of means. So mean of the sampling distribution of means means first we should construct the sampling distribution, sample distribution. How do we get that sample distribution? By applying of that simple random sampling with replacement technique. First we need to select the samples from that population based on that sample size 2. Here the number of possible samples in simple random sampling with replacement, we get capital N power small n. So here the formula is capital N power small n. So how many possible samples we get? 25 possible samples. So here the given population size is 2, 3, 6, 8, 11. So these 5 observations are the population observations. No? So we from this population we need to select the samples with size 2. So 25 samples we may get. So here with replacement means the values are the whatever that samples we have chosen, those are repeated. Means here the combination 2, 3 and 3, 2 both are same, but we are considering these type of combination also in this simple random with replacement. So in without replacement we are not considering because these two are same. So repetition not considering in simple random sampling without replacement. So here we consider all the repeated values also. So the possible combinations 2, 2, 2, 3, 2, 6, 2, 8, 2, 11, 3, 2, 3, 6, 3, 8, 3, 11, and 6, 2, 6, 3, 6, 8, 6, 11. So like that 2 combination of pairs, here 25 samples we get. So means after getting of that samples for each sample pair, that 2, 2, 2, 3, that pair of samples we got now. So for each pair of sample we should calculate the mean. So now compute the arithmetic mean for each of these 25 samples, which gives rise to the distribution of means of the samples, known as sampling distribution of means. So once we calculate the means of that samples, we get the sampling distribution of means. After getting of this sampling distribution of means, again we calculate the mean of this sampling distribution of means. So that denoting with mu x bar. So means sum of all these 25 values and divide with 25, you will get 6 values. So this is the mean of the sampling distribution of means. And last bit, they have asked that standard error of the sampling distribution of means. So using of all these 25 values, so you should subtracting the mean value. So that mean we got that it has 6 now. Mean 6 from each number in sampling distribution of means. Sampling distribution of means, all means are nothing but all these values, means, and squaring the result, adding all 25 numbers, thus obtain and dividing by 25. So means do the sum of all the values, all the values from the mean, the sampling mean values are deviated, and do the square of those values. After doing of that, after computing of that square of that values, add all those values and divide with that 25, you will get the variance of the sampling distribution of means. Once we get the variance, the standard error of sampling distribution of mean is equal to sigma x bar, that is equal to under root of variance. So you will get the 2.32 value. So here you should remember, whenever that sample can be selected by using of that simple random sampling without replacement technique, the number of possible samples are NCN. In with replacement technique, the number of possible samples are capital N power small n. So these are the problems. Thank you.
Like, share and subscribe. Hit the bell icon for more updates.